Lesson 7.0C is the circle definitions. So, first of all, in general, circles are sets of points all around the edge. It's called points in a plane. That means they are equidistant meaning from the center. So if I do the center right there, every point on this circle is the same distance away from that point in the middle. Okay? So, a circle is named by the center or circle P. Okay, so if I put a point P there, that will be circle P. Okay? Next, we have radius. What part of a circle is a radius? Well, we also call the middle an origin. So there's our origin. Okay. A radius is then how big? Halfway. It's from the edge to the middle, to the center. So this guy's a radius, this guy's a radius, this guy's not a radius, and this other side, if you continue from here all the way to the edge, that's not a radius. That's a different name. It gets a different name. How does that one give a different name? It gets a different name because he's twice as long. What is twice as long as a radius? Diameter. A diameter. Good job. Okay. And that's what this one's talking about. So it's saying diameter is the longest chord. In this circle, the diameter is the one that goes edge to edge, and it must go through the middle, which is again called the origin. Okay, it's its original point. We don't know what that point is, unless it tells us the point exactly. So that's why we always call it the origin, the original point. And it contains the center of the circle. That is one of the key things, is it contains the center of our circle. It contains the origin. That's what the diameter does. And it's called a chord as well. It's our longest chord. Well, so far we don't know what a chord is. Let's investigate that part. So a chord is a segment that joins 2 points on the circle. It says on the circumference, meaning the edge of the circle, not the interior. So that means any line joining edge to edge is called a chord. Okay? Anything going edge to edge is a chord. Edge to edge is a chord. Anywhere you want. Okay? As long as it's edge to edge. Now, can a chord go through the middle? Heck yes, that's why it's called a diameter then. Okay, there's only one specific chord that will go through the middle, and that is your diameter. Okay, let's pretend that goes through the middle there. There we go. Alright, that will be a diameter, and yes, it's a chord. Yes?
It's this, that.
Being the interior means it can't join points on the inside and then stop. So, for example, if I've got a point, let's say, well, even just the center, from the center to the edge, that's a radius. That's not a chord. Okay? And it's not a chord because it doesn't reach the edge to edge. And let's say there's a different point down here. If I took a chord and went right to there and stopped, and it didn't go right to the edge, that wouldn't be a chord. Chords have to go edge to edge. Good question.
Could you make a chord like on an angle?
No, a chord was always a straight line. It'll never be curved. I just draw really badly, so some of mine look curved, but they're not supposed to be curved.
Can you go through dots in them, like?
Oh, you can definitely join dots through the middle, but you've got to go edge to edge. Now, you can't go dots to dots, so I couldn't go like this. Starting here, go up to here, and over there. That's not a chord. Okay? Even though it goes edge to edge, a chord is a straight line going edge to edge. Now, it can contact other points in the middle of it. Absolutely, go through those points. But it absolutely has to be a straight line. It cannot be a crooked, intersected line like these guys. Okay? And it has to go edge to edge. Very good question. All right. Secant. Well, this is the exception to the rule. This is a line that is a chord, but it extends beyond. So he gets a new name. We don't call them a chord because chords have to stop at the edge of the circle. Secants get to go beyond the circle, but they go straight through. So any line going straight through the circle that is a straight line, it's not being chopped in half and it's not being zigzagged at all. Any line going through is going to be a secant as long as it's going through. Okay? Secants going all the way through. Okay? Can they go through the middle? Yeah, they can. So if I wanted to go right through that middle, I sure can. Now this one right here, this will be a secant. I'm going to call this I'm going to call that D, and this C. This line right here, that's secant, it contains these 2 points. I'm going to call EF, which is this part, which is my diameter. Can a secant contain the diameter? Yeah, it can. Okay? It just means that the diameter extended beyond the circle. Okay? So the edge parts here, this part right here would not be considered part of the diameter, and neither would this part here. That's part of the secant line. Okay? That's not part of the diameter. The red line would be the diameter. Okay? Connected to that piece. All right. Any questions so far? Excellent. Let's keep going. Tangent. This is going to be lesson 1. We're going to talk all about tangents in lesson 1. So, tangent is a line that is outside the circle that intersects, which means touches, the edge of the circle at only one point. Okay? So it's a line on the outside of the circle that only touches your circle at one point. It'll touch the circumference. It won't go through the circle. Okay? It touches the outside. So I can draw all kinds of tangent lines as long as I only touch one point. Okay? I'm going to touch one point on the circle, and that's my tangent line. That's all. Okay? Now, the point where it touches the line, this point here, point C, this point here, all of those where it actually touches the circle, that's called point of tangency. Okay? That's called the point of tangency. Any questions so far? Okay? Okay, moving on to the next part. Central angles. We need to talk about central angles. All of those I've drawn there in different colors are called central angles. So if you've got some colors, you might want to highlight each of those a different color. Okay? Now, central angles are angles that start at the edges and they meet in the center at the origin. So really, the line that starts at the edge and goes to the middle, or it starts at the middle and goes to the edge, what do we call that line? Halfway across the circle. A radius. So the central angles are formed by two radiuses. Now radiuses is not a word. To pluralize radius, to make it sound like more radius, you say radii. Okay, radii. That's why it is two i's on the end of the word. Okay, radii. So, this here is a radius. This here is a radius. Those are radii together. So this guy was formed, that big green angle was formed by those two radii. Okay? So that's the central angle. It's the angle that's connected to the center right here that I've shown. Okay? Any questions about that? No? So think central angle meets in the center. Central, center. Okay? That's a good way to remember it. Now remember, when we're naming angles and you want to know what angle we're talking about, and you label 3 letters, you always talk about the one that's in the middle. That's the one they're talking about. If there's 3 letters there. Okay, so here they're saying angle B. And yes, angle B should be in the middle because he is the middle point. He's our origin point. Okay? All right. Let's take a look at inscribed angles. Inscribed angles whose vertex means outside point, so whose points are on the edge of the circle. Okay? They're on the edge of the circle. And the sides are determined by 2 chords. So I've got a chord here that goes edge to edge, and I have a chord here that goes edge to edge. Where they meet forms an angle. That's called an inscribed angle. Okay, it's inscribed, it's inside. The angle's inside 2 chords. Okay, so inscribed, angle inside 2 chords. Now, remember, you can use the radius as a chord. So watch. I could draw a radius, a diameter. So I could draw your diameter going this way. He's a chord. Now I can go like this. Boom. That's an inscribed angle right here. Okay, that angle right there. Now, can the diameter form an inscribed angle? Did it form it? You bet it did. Because diameters automatically touch the edge of your circle. And then I just had to take one of those edge points and draw another line. Okay? Draw another chord. Any questions on inscribes? Yep.
Can you to touch in like the middle, or does it
Never.
have to be?
Never. If they touch in the middle, they're called central. Okay? So middle is central, outside is inscribed. Okay? Good question. Next one's an arc. What are arcs? These are sections on the outside of the circle, the edge of the circle. The edge of the circle all the way around is called the circumference. So on the circumference of the circle, the outside of the circle, that's where you get your arcs. Now, arcs that are less than 180, okay, so less than a straight line, are going to be called minor arcs. Arcs that are larger than 180 are called, or equal to 180 even actually, so equal to or larger than 180 is going to be exactly called a major arc. So, as you can see, the red arc is our minor arc because it's tiny. It's less than 180 degrees. It's less than a straight line. And it's less than halfway around the circle. Okay, the major arc is the blue one. Now, sometimes when you're talking about arcs, you have to tell what direction it's going, clockwise or counterclockwise. So if I have point A and B here, I would say major arc, it would be from B to A clockwise. If I go B to A counterclockwise, the other direction, it becomes a minor arc. Okay, so you always have to indicate what way you're going, clockwise or counterclockwise. Okay? Yes, if they're exactly 180, you'll have two major arcs. So a semicircle has two major arcs. Good point. So if I cut this guy in half, this would be a major, this would be a major. On the outside here is what I'm talking about. Okay? Good question. Next, we're talking about sector. A sector is like a section of the circle. Think of it as a piece of pie or a piece of pizza. That's all a section is. And when we cut pies or pizzas, we cut it from the middle. And that's exactly what it is here. So really, a sector contains what kind of an angle that goes to the center? What kind of angle is that? A central angle. Okay? So sectors are pieces of the pie that contain a central angle. Okay? And again, they're formed by who? What are these guys? Radii. Those are radii. They're halfway across the circle and they touch the middle. So they're called radii. Okay? Better? Yes, ma'am.
So is a sector just what you call the central angle?
You could. You could. A central angle does make a sector. Absolutely. Very well said. All right. Moving on to the last part here. So, subtended is a big word we use in this topic, and that means contained or found on. So if I said the arc are subtended by 2 points, that means they're found on the arcs on the edge of the circle, 2 points on the edge. Okay, so if they're subtended. So here I could say angle A to B to C, so starting from A all the way up to B down to C, that arc is subtended, so found on or containing 2 points on the edge of the circle. That's what it's saying. But they're going to use that word subtended. And it's one word that means a lot of words, so it's shorter to say something. So we'd say, okay, this inscribed angle and the arc is subtended from points A, B. Or you could say it is subtended from the minor arc AC. Okay? So that's how you would describe it. Instead of saying, okay, I've got an inscribed angle from A to B to C, and it is found on and starting at the points A and C. That's a lot of words to just say subtended. Okay? So subtended is the short form of saying the same thing I just did. Here we have an inscribed and it starts here. Okay? That's what that means.
So it's just
it's a descriptor word.
it's basically just an inscribed angle with a it's describing an inscribed angle with a longer arc.
Yes, that's exactly what it is. I could have put central angle in there. I could have did this, 2 different radii, and I could have called that D and E, and I would say that this inscribed angle, and I'll call that O for the origin, I could say the inscribed, or the central angle, DOE, is subtended by arc DE. Okay, minor arc DE. Okay, so it's another way of saying it, absolutely. So here's all our points. This you can see right here, this says L, oops, This one says L1. This says L3. That's line 1, line 3. Oh, no, sorry, that's L4. Pardon me. That's L4 on top. L3, this is L1. L5, line 5. Okay? I don't know where L2 is. I guess they skipped an L2. They just did 1, 4, 5. 3, 4, 5. Okay. So, let's try and figure out what what letters form certain lines. Okay. Do this for homework, and we'll get back to this one another time. This one's not photocopied very well, but these ones are. Let's try this one. This is actually the same thing. I should have deleted that other page. This is the exact same thing, but I made it bigger for you. Okay, this is the exact same thing. So this is L4, L3, L1, L5. Okay? And you know what? We're going to change L5. We're going to give him a new name. We're going to call him L2. I don't know where L2 went, so we're going to call him L2 instead. So, we need to be able to do every single one of these. Okay? Give it a try and see if you know what they are. Give it a try, and we'll come back to it together in a moment. So take a look at all of the different radii we found. And yes, the radii can be found in the diameter. The diameter contains 2 radii. So if I look at the diameter, I've got one diameter line going right here, and it contains 2 radii. But it is a diameter. So my diameter goes from A to B. And it includes O, so you can actually say AOB. It includes that center one. Same with this one here. I've got from C, O, and D. So we put our O in there, and I've got COD. All of those ones, all are diameters. Okay, because they go edge to edge and touch the middle. Okay, they contain the middle. Secant lines. Who can find a secant line? Yep, right here in the front. Sorry? A secant. So we got line 1, line 2, line 3, or line 4?
Oh, line 1.
Line 1, good, line 1. Because it goes through the circle. To be called a secant, it actually has to go through the circle. It can't just touch it on the edge. That's a different name.
Line 4.
We have one more that is also. Give us?
Line 4.
Line 4, good. Okay, so 2 secant lines. Now we want a tangent line. We've got a couple of those. Which ones are tangent lines?
Line 2.
Line 2 and line 3, good. Okay, point of tangency. That's where the tangent line's going to touch. What are our points of tangency? C and Y, good. C and Y. So funky Y. All right, inscribed angle. Does anybody see an inscribed angle anywhere? Oh, there certainly is one. Yes, sir. Inscribed. It's going edge to edge. Yep.
A, O, and X. Is that one? Or is it
AOX, so that's a radius here. That's a sector. How about this one right here? That is an inscribed angle. It's connecting 3 edge points. That's what an inscribed angle does. It connects 3 edge points. Okay? So the inscribed part is right there. So when you describe this inscribed angle, that letter C, because that's where the angle's formed, has to be in the middle of the 3 letters. So we would say it is D to C to H. So D, C, H. Which one? That's R? Oh, this one's R? Oh, okay. It's an R on H. Thank you. D, C, R. Oh, yeah, H is down here. Okay, central angle. We've got a few of those. We've got quite a few of those central angles. So, what are our central angles? AOD. Okay, another central angle. Okay? So, AOD. XO to A, sure. The O will always be in the middle. Where's B? B to O to C, sure, right here. Whoops. BOC. Where else? Yep.
Could D to O to B?
Absolutely, that's a big one. So DOB. Now look at what I'm going to do with the next ones. We have quite a few more. I'm just going to erase all my lines on the inside of the circle so I can describe them and show them to you. So watch carefully. We have lots of central angles. I could say this is a central angle from here to here. I could also say this is a central angle from here to here using all of it. Okay, it's another central angle. I could use just this one, or I could use from there all the way to, whoa. I could use, let's just take that away. This one from here to here, that's a semicircle, that's one central angle. The other side would be the other central angle. Okay, so there's lots of central angles. Almost every line from any radius is a different size of central angle. So there's tons of central angles in any circle if you've got lots of lines. Okay, as long as they go through the center, the origin. Okay, those are central angles, which means that comes to number 9, sectors. Central angles include sectors. We call sector contains a central angle. So all of the ones we had for central angles are the same as number 7. Okay, because the sectors are going to contain that central angle because they're formed by 2 radii as well. Okay, so each piece of pie here. So I can take my pieces of pie and do this. You can cut it any way you want. If you get all hungry up and you want to go, I'm eating half of that pie at home. Excellent. You might actually say, oh no, I don't need half the pie. I'm just going to have a little sliver. I'm going to eat that piece. All of those are sectors. You might also say, okay, well, I'm going to share. You might eat this piece and share it. You can also divide that into more. Those are more sectors every time you divide that. Okay? So lots of sectors. Chord. Let's find some chords now. Where are the chords going to be located? What do you have listed for a chord? There's a couple of them. How about right here? R to C. That's a chord. It's contained in a C cant, but it's still a chord. So R, C. What else? Q to P. Beautiful. Absolutely. There's 2 more. 3. Where's the other one?
Oh, wait.
2 diameters. Diameters, remember, are called your longest chord. So from A to B, okay, and C to D. Okay, diameters are your longest chords. So yes, they're chords. Major arc. Major arcs and minor arcs, there's going to be as many as there were sectors and central angles. So take a look. I could have a major arc all the way from here all the way to here. I could have another one that goes from here and stops and goes maybe all the way to there. Those are all large arcs. You could start at a different spot. You can say, oh, I'm going to start here instead and go all the way around. As long as it doesn't make a full circle. Those are all major arcs. Same as the tiny ones. You could have tiny arcs, and you can make a teeny arc right here, AB, or A to D. Another tiny arc that doesn't make a full half circle. Okay, there's tons of them, same as we found sectors and central angles. Semicircles are specific. Yeah, last one here, semicircles. Semicircles form exactly how a circle. We've got one on either side of that green line. We also have one on either side of that yellow line. Okay, so there's 4 different semicircles. Okay, because remember, a semicircle must go through the middle. It must touch that origin point. This concludes circle definitions. Check your work.